Good morning, guys. I hope you had a nice weekend. Today is Monday, March 30th, and today we are going to learn about double angle identities. These identities that I have listed here are also on your sheets. Okay, if we go back to that wonderful sheet that I gave you last time we saw each other, here are the double angle formulas. So they're right down here, okay, on the sheet. All right, let me look at them here because they're a little larger. Okay, double angle formulas. Okay, the sine only has one. It's 2 times the sine of that angle times the cosine of that angle, whatever angle we want to find a double angle of. Cosine a double angle. There's 3 cosine formulas. Notice the first formula has both the cosine and the sine in it. The second one has only the cosine in it, and the third one has only the sine in it. Okay, and that's going to become relevant based on the given information. If they only give you the sine of the angle, you use this formula. If they only give you the cosine of the angle, you use this formula. Obviously, for the sine formula, you're going to need to know both, and we're going to see that in the first example. And then we have the tangent. Did you ever notice all the tangent formulas are in fractional form? Okay, because the tangent's always a sine over the cosine. So the tangent double angle formula is 2 to the tan of theta, 1 minus tan squared theta. And today we're just going to do some little problems with it. So I'm going to begin with this example. I'll keep this handy. Okay. It's saying if the sine of a certain angle is negative 7 over 25 on the interval between pi and 3 pi over 2, find the double angle of sine, the double angle of cosine, and the double angle of tangent. Now remember, for the double angle of sine, we definitely need to find the cosine. We don't know the cosine right now. We only know the sine. So we're going to have to first, step 1, in this particular case, because they're asking us for everything. For example, if they had just asked me to find the cosine of a double angle, well, I only have the sine of that angle, but I have a formula that only contains sine. So I could just substitute it into this formula and move on. However, they're asking me for everything. So the first thing I need to do is find the cosine. And since we need to find the tangent of this, the tangent of the double angle, we're going to have to find the tangent also. Well, first of all, it tells me where it lives. It tells me it lives between pi and 3 pi over 2, which means that I'm here in this quadrant, okay, in quadrant 3, because here's pi, and here's 3 pi over 2. And we know the angle is formed between the terminal side and the x-axis. If the sine is 7 over 25, if I look at this angle, sine is 7 over 25. Okay, then what I would have to do is I'd have to find the side adjacent. Using the Pythagorean theorem, excuse me guys, the Pythagorean theorem, this is 24. Okay, so now I know what the sine is, the cosine, and the tangent. If you want, you can list it out. That the sine of theta is already given, that's 7 over 25. The cosine of theta, now we're in quadrant 3, so cosine is also negative, negative 24 over 25. And the tangent of theta is opposite over adjacent, and it's positive because we're in quadrant 3. Okay, so now we're going to find, using all these values, first the sine of 2 theta. The sine of 2 theta says it's 2 times the sine of theta cosine theta. 2 times the sine is negative 7 over 25 times the cosine is negative 24 over 25. Okay, I actually did the math before I did the video, so I know that when I multiply this whole thing out, move this over a little bit, I'm going to get, well, negative is positive, 336 over 625. As you can see, nothing can be reduced in here, so this is your final answer. Now, the cosine of the double angle. Okay, I could use any one of these formulas. Okay, I could use the cosine squared, sine squared, because I have a cosine and sine. I could use the cosine of the sine. Since they gave me the sine formula, the sign in the original, I'm going to use that formula. So that is 1 minus 2 times the sine squared theta. 1 minus 2. The sine is negative 7 over 25 squared. Okay, I'm going to do all the math, and I actually did it before the video to save some time. And the whole thing, of course, I'd square this first, multiply this by 2, put this over the same denominator. Or, of course, you can use a calculator, but your answer should not be in a decimal. Make sure it's in fractional form. And that's your answer. Okay? And the last thing is I'm going to do the tangent of 2 theta. All right. And here I'm going to show you a trick. Instead of using the formula, we know that the sine over the cosine, the sine of any angle over the cosine of any angle is the tangent of the angle, right? That means that the sine of a double angle over the cosine of the double angle is equal to the tangent of the double angle. So rather than use this and simplifying this whole big fraction, you can tell me that the tangent is the sine 336 over 2. I'm sorry, I wrote 2 there. I don't know why 6. Cameron, did you catch that one? 625 over 527 over 625. If it's sine over cosine, your denominators are the same. We know that they're going to cancel out, and you're going to be left with 336 over 527. Okay, so there's the sine of the double angle, the cosine of the double angle, and the tangent of the double angle. So for the tangent, you don't have to use that big formula. You can just do sine over cosine. All right, I'm going to try another one with you, and basically that's the whole lesson for today, and I'm actually going to assign you problems in the textbook for homework. Okay, so let's try another problem. If the cosine of theta is 3 over 5 on the interval, and in your book, on your textbook, sometimes the interval is given in degrees, not radians. 0 pi over 2. So what quadrant am I in if I'm in that interval? Well, I'm in quadrant 1. Okay, we're going to find the sine of the double angle, the cosine of the double angle, and the tangent of the double angle. Okay, well, we are cosine of 3 over 5, so let me find now everybody else. I need to find the sine. And actually, technically, I don't need to find the tangent now that I know that little trick. So if the cosine, I'm in quadrant 1, cosine is adjacent over hypotenuse. We recognize this to be a 3, 4, 5. The sine is 4 over 5. Nice and easy. So now the sine of the double angle is equal to 2 times the sine of theta cosine theta. Okay, so it's 2 times the sine is 4 over 5. The cosine is 3 over 5. This is going to be 24 over 25. When I multiply that out to do the cosine of the double angle, since they gave me the cosine, I'm going to use the cosine formula. It's 2 cosine squared theta minus 1, 2 times 3 over 5 minus 1. Okay, again, this would be 9 over 25. This would be 18 over 25 minus, make this 25 over 25. And this is going to be a negative 7 over 25. Even though it's in quadrant 1, the double angle is negative. And then to find the tangent of 2 theta, excuse me, guys. And guys, since sine and cosine is going to have the same denominator because it has to be the hypotenuse, excuse me, I need a coffee. When you do the tangent's always going to have the same denominator that's going to cancel out. So it's going to be 24 over 25 over negative 7 over 25, cancel out, and it's going to be negative 24 over 7. So that's the double angle formulas, okay? So tonight for homework, okay, I wrote down the numbers, but I didn't write down the page. Let me get to the page, 352. So your homework is page 352, numbers 1 through 7. Okay, in tomorrow's video, I'm going to post the answers for tonight's homework and the answers for Friday's homework, and all the work worked out in the video. Okay, that's going to be tomorrow's video, just going over your homework. So make sure you have all your homework done by tomorrow. I am checking that your homework was due, but I'll post the answers tomorrow. Have a great Monday, guys. Be good, be well. I miss you all. Be nice to one another. I know this is getting really tired being in the house. And stay in the house, okay? Social distancing. Bye-bye.